right? So what does this question states? Like initially you're given an n concert tickets, and there will be m customers will be coming, and now they'll try to buy each a concert ticket. Now what is the condition? The maximum price that they are willing to pay for a ticket is the nearest possible price, such that it does not exceed this maximum price. Like here the first person is willing to pay a price of 4, a maximum price of 4 for a concert ticket. Now he'll go and buy this concert ticket, which is a price of 3, right? So our output is 3. Now the second person has came and he is willing to pay a price of 8. Now he bought a ticket which is worth of 8, right? Now again the third person came and he is willing to pay a price of 3, but there exists no concert ticket which is less than or equal to 3, because this 3 has been already bought by this 4, right? So there exists no concert ticket which is less than or equal to 3, right? So this is how we need to do this problem. Like you can ask me how we will solve this. See here, let us take this. First of all, let us take this sample case, which is 53785, right? So I'll be sorting this array. So this is 3 5s 3 5 5 7 8, right? Now our customers will be arriving in the order 483, right? Now see here, when I'm saying like this, can I say uh, the basic concept is you need to use the upper bound and lower bound, like through binary search. Now I'm not teaching you what is lower bound or what is upper bound. Like I'll just give you a basic intuition. What is that? If see here, if I say lower bound of some value, it will be it will be giving me any value that is greater than or equal to the given element, right? It will be giving me any element which is greater than or equal to. See here, let us say for suppose I'm taking a lower bound of 4. I'm taking a lower bound of 4. Now it will, if there are any elements that are greater than or equal to 4, if there are any elements which is greater than or equal to 4, then that will be my first element. See here, in this array lower bound of 4 will give me 5, because 5 is greater than or equal to 4, right? 5 is greater than or equal to 4. Now if I say upper bound of 4, it will give me an integer which is strictly greater than 4. It will be giving me an integer which is strictly greater than 4, right? So that's what it is. Like if you still have any doubt, like just refer to some online articles or something. Yeah. Now what we'll be trying to do, we'll be trying to do use this lower bound, right? See here, yeah, sorry, we'll try to use an upper bound. See here, for the upper bound will give me an index 5. That means, can I say when I'm using upper bound, I know that it will give me definitely a starting value which is greater than 4. That means, can I say my previous index will be definitely that will be less than or equal to 4, right? If I'm applying upper bound, I know it will give me the starting index which is greater than 4, right? Now can I say the previous index of my upper bound will be definitely which will be less than or equal to 4, right? Now see here, we'll be taking some multiset. We'll be taking a multiset, and we'll try to insert this element so that elements will be sorted in the container. And now see here, and now here the customers arrive in the order 483. Now I'll use upper bound of 4, right? What it'll give me, it'll give me this element which is 5. Now what is the previous index of 5? That is 3, right? That is 3. Now this is the ticket that I can buy. Now what I'll try, I'll just take that number and I'll erase this number in my set. I'll erase this number in my set. Now I again go for 8. I'll go for 8. And now I'll try to use upper bound of 8 on this whole set, right? Now what it'll give me, it'll give me the end of, see here, greater than 8, there exists no integer which is greater than 8. So it'll point to the end of the array, right? It'll be giving an iterator which is pointing to the end of the set. Now what is the previous index of that iterator? That will be 8, right? So we'll be taking this 8. So we'll be taking this 8 and we'll print it in our answer, and we'll erase this number. Now again we come for 3, and now you'll again apply upper bound of 3 on this set. Now what it'll give you, it'll give you 5, right? It'll give you 5. But if you look at the previous iterator of 5, there exists no element, can I say it? So there won't be any answer for this 3, right? So that is how you need to make. So basically, for solving this problem, you need to know multi-set data structure, how it works, and the knowledge of and lower bound upper bound and lower bound. Yeah, if you have knowledge about these things, then you can definitely solve this question. So yeah, so let's just quickly get into the coding part. Yeah. So yeah, this is there will be n concert tickets and m number of persons, right? Right. So what I'll be taking is, first of all, concert tickets. Like I'll be taking as tickets, which is of n size. Now I'll be taking another vector, which will be customers, right? Those will be customers. So I'll take it as customers. And I'll take the input, which is my custom file. And after taking these tickets and customers, now what we'll be trying to do is, I'll be taking a multi-set, right? I'll be taking a multi-set, and whatever the concert tickets that are available right now, I'll just insert that into my set. I'll just insert that into my set. Now after inserting here, what we'll try to do is, now we'll iterate in the customers. Now see here, the maximum price is our current. This is the maximum price that they are willing to pay, right? So now what we'll be trying to do is, we'll be trying to apply this upper bound, right? Upper bound of this maximum price. This maximum price will be applying, like, and see here, if your IT is equal to st dot begin, then can I say there exists no element previous? Like if it is the starting element, can I say there exists no previous element? So in such cases, we just need to print a -1, or otherwise we can just decrement, and we need to print the previous element, right? If you carefully observe here, see here, for 4, what we have done the upper bound of 4, right? We have done the upper bound of 4, which which has given us 5, right? Which has given us 5. Upper bound of 4 has given you 5. You need to pick the previous element. So that is what we are exactly making over here. I have taken upper bound of 4, which should give me 5 over here. So I check here whether my 5 is starting element or not. If it is my starting element, I could say that there exists no previous element. In such cases, I have printed -1, or otherwise I have just decremented my iterator and I have printed this previous element. So yeah, that should be the answer. I'll just quickly run through this. Yeah, so here I have redeclared it. So yeah, you can just simply, there is a declaration class, right? So, so so here what I have forgotten is, you need to erase this element in your set as well. I have just forgot to erase that. Yeah, now it is running fine. Now it is running fine. Now I'll just quickly submit this off. Yeah, you see, it does run fine. It does run fine. So if there are still any doubts, just comment me down. I'll